Yeah. I just hang around with all the other passengers, looking in their window.
I'm at the beach now, guys. Look, the plane just got off. So.
Wow.
You also sent me this, Emma.
How'd you survive the landing?
Emma sent me.
That's what. How
you guys also want to see one? The landing? Oh, it's lovely. Look at my wonderful hotel, guys. Isn't it beautiful? It's only like $5 every week. It's amazing.
Wow.
That's a good help.
Guys, look at the furnace.
How are you moving so fast?
I don't know. I'm teleporting. Oh, guys, let's go to Simba Land. Let's go to Simba Land. Oh my gosh, we're in Disney World. Look at that. We're in Disney World, guys. We're in Simba Land. Yeah. Oh wait. Let's go look at the mural in my hotel room.
What?
The mural in my hotel room. Isn't it beautiful?
Watching the green screen be like.
I know.
The green screen.
Oh yeah, you guys want to see yourselves? Wow! Oh my goodness!
Oh wow! What class is that from?
Bro, that was like years ago. That was whenever Oliver still attended the class. Oh guys, isn't this amazing? I saw this random person.
No, Lord, back up. Hey Emma, look at the picture.
Mushroom Land. Also a picture sent from Emma.
Mushroom Land.
This is Emma's mushroom. Whoa, where are we, guys? Does anybody recognize that maybe this is?
All right, Lola. I'm gonna start the class, Lola.
Is that? No, this is not the. Oh,
yes, we shall start the class. This is gonna be easy class today since it's my birthday. I say,
happy birthday.
Easy class.
Happy birthday.
Happy birthday to you. Everybody sing it. Happy birthday to you. Happy birthday to you. Happy birthday, dear Tara.
Bro, we're all birthday to you.
Happy birthday to you.
I love it. Thank you guys.
We
You're
At
gotta
least we
do
tried.
it.
At least we tried.
That was the most pathetic birthday song I've ever sung.
I
tried to.
You should not be doing math on your birthday. This is sacrilege.
Unless,
Okay, guys.
You
Victor gave me a plant.
Hey, I was part of that
you go
too.
chompy.
That's true. Emma and Victor got me a plant.
It's a nice little plant there.
The piranha plant.
Should have gone to see the Mario movie for your birthday today.
We should have
see it on
tried, but
Thursday.
it doesn't. Yeah, it doesn't come out till Wednesday. Tomorrow it comes out, I think.
Oh, okay.
We have
Came out
I thought it was
Sunday.
out already.
we have coding class tomorrow, so Thursday we're
That's weird. You know, in Texas, it came out on Sunday.
Is that Canadian
So
time?
yeah.
Is that Canadian time?
Yeah, it's different time zone.
Yep, it is. All right. So here are we'll start with the math competition questions. You had three of them plus a riddle. Does anybody, I'm gonna show you these in case anyone wants to jot them down. I'm assuming everybody has them, right?
Yes.
Yes.
Have these. Let's see. Oh, is somebody leaving or joining? Okay. Okay, so Desiree's coming on. It's her birthday too. We got to sing happy birthday, Desiree.
Happy birthday.
Twinsies.
Yeah.
Happy birthdays.
You want to sing happy birthday to Miss? Oh, well, let's see. Desiree, you on yet?
All right. So do you want me to answer that honestly or not honestly?
Answer what, honestly?
Have you done the questions? Yes, honestly.
No, not like that. But I tried
Did you
number
want to do
one.
questions?
I looked
Gotcha.
I looked at the riddle. It just about broke my mind. I held it up to the fireplace and nothing happened.
I think
I held it up to the fireplace and nothing happened. So I got sad.
I mean,
All right. So do you want to start with the riddle
reveal
first?
the answer.
All right. So who has the answer to the riddle?
Well, let me read the riddle. I think I've seen this before.
Okay. Who wants to read the riddle out loud?
Okay.
I'll just give my answer to the riddle. Someone else can read it.
I'll read it, but I never did it, so I won't know the answer.
Okay, well, who wants to read it?
Me.
Okay, go for it.
A man with unequal qualities could be called a mathless guy, but if one is without any matches, that term could also apply. You perhaps should go and get some. It'd be well to suggest, because to try the following problem with matches is the best. It is best. The arrangement that is shown below is deliberately falsified. Can you make a simple equation true by moving one match to the other side?
So, I'm assuming these are Roman numerals, and I'm like the one on the left side. I'm assuming it's 2, and the one on the right side, I'm assuming is 4, maybe 5.
That's what I thought of first.
No, my answer is no. You cannot.
You can.
Is that? I don't know my Roman numerals past.
So I'll give you guys a hint. It does have to do with what we've been talking about.
Can I please show my answer? Can I please show my answer?
You can show your answer.
So you take this, like one of these matches, turn it sideways and make this into like I equals square root of negative I.
Oh, okay. We got a negative I in there. Yeah, so it does have to do with square root. So you take that match, or one of them, either one, and it should look like I equals, and you know how the radical sign looks?
What's the radical sign?
Yeah, radical sign is...
So that match goes right here.
That's what I did.
Yeah.
I'm smart. I got it right.
Yeah.
You're
smart. I don't know if you guys remember, but I equals the square root of I because
it's
negative I.
That's right. It would have to be a negative I. Yeah. I equals square root of negative I. Yeah.
I equals negative I. No,
Yeah.
I equals the square root.
So that's the answer to the riddle. That's right.
Wowzers.
Yep. So it has to do with all of our square roots and our imaginary numbers. I thought it was a good riddle for what we're talking about. All right. Does anybody want to do the first problem? Do you know how we do the first problem? Do you remember?
I mean, I'll try maybe. Let me try and work this out first.
Okay. So this is, we're going to be using the FOIL method. Who remembers how to do that?
I have no idea what the FOIL method is.
Okay, so that's all that is it's an acronym for first, outside, inside, last. So we're going to multiply first terms and then the inside terms together.
That's what I did.
Outside and then the last terms together. All right, so what'd you get?
For my answer, I got 20.
Very good.
Oh, let's go.
All right, so there's our first, our inside, outside multiplied together, and last multiplied together. Did anybody get anything different?
That's feel.
Nope.
Oh, sorry. You're right.
Yes, that's feel.
You guys always. There we go. Good thing this is in spelling class, huh? All right. Does anyone want to do number 2? All right. Square root of I, or sorry, square root of 1, I guess, is
1.
Square root of 1 is 1.
Okay. Just like we had in our other, let's see.
The square root of -1 to the square. The square root of -1 squared is just -1.
Okay. Or I have it as I because you. Yes, that's right. Except for this is on the outside, so the last one would be 1. This is on the outside.
Yes.
Yeah. Okay, so here's the answer right here. We have I, square root of I, and 1. You add up the exponents here, and you get I to the 3rd times 1 is just -I. So the answer, how we're going to work all of these is going to be up here. So this is going to be our original key up here. It's the powers of I, right? So you got to know that I to the 1 is I. You got to know I squared is -1, and I equals the square root of -1, right? And then once you know that, you can get higher powers of I all the way to 4. And once you have this key, all you're doing is plugging in, let's see, all you're doing is plugging in each one of these answers, right? And this last one here is the exact same with powers of I, right? We have 18. Do you remember what the key to that is? What we have to divide by, guys?
Just divide I by the
1
4.
To the power of 4.
I4.
Yeah, because that equals 1, right? So 1 times that makes life easy is why it's kind of like a trick, right? So if you can pull out any of these I to the power of 4s, that's just going to equal 1. And then 1 times whatever it is that number. So we're just saying how many I to the 4s can we pull out? And so that's called division. And once we divide all of that, we get whatever the remainder is going to be the answer. Because you're just multiplying it by 1, right? Because I to the 4s are 1. So did anybody get -1 as your answer?
No, I got, well, divide for 2 or 3.
So I divided right here. We divide 4 by, or 18 by 4, however you want to say it. And our remainder's 2, right? And in this case, it's a -18. So our remainder would be a I to the remainder -2. And we pulled out a bunch of I to the 4s, and those just equal 1. So that makes it real, real easy. So then I just have to know I to the -2, what that equals. Okay, do you see how that works? So I would rather you understand the concept than each of these details. So in this one, what is the remainder on I to the -9? So if I divide I to the 4 by that, what is my remainder? Hold on just 1 second. I think I heard Victor. Okay. He screamed. Make sure he's okay. All right. So basically you're dividing 9 by 4. What do you get? How many times can 4 go into 9?
Twice.
2.
2. And what is your remainder?
1.
There you go. So here it is.
Just 1.
There's your remainder. I to the -1, because this happens to be a -9 that we divided by. Okay. I to the 0 is just always going to be I to the 0, which is 1. Anything to the 0 power is 1. All right. Here's our I to the 9 again. What's our remainder, guys? I to the 1.
I to the 1.
Okay. So 18 divided by 4. What's our remainder in that? How many times?
I squared.
4 can go into 18 how many times?
4.
4 times.
4 times with a remainder left over of 2. Do you see that?
Oh, that makes more sense.
Okay. So because what you're doing is you're just taking out all the I to the 4s as the trick, because that just equals 1. It doesn't matter how many times you're going to put I to the 4 on there. It's always going to equal 1. So your remainder is really the key to these problems. And once you have your remainder, I squared, well, that's going to equal -1. So now you can start piecing it out and adding those up, okay? So I don't want to get lost in the weeds, but the concept of this is the trick. When you have i's to high powers, you always just divide the exponent by 4. So you can get the number 1 to multiply whatever the remainder is. Okay, so if you're in a competition or a test or whatever, that's going to be the key to high I exponents. Cool? That's always a tough one. All right, today I want to do something a little different. I told you guys we were going to start linear equations today.
Well, what's a linear equation?
That is a great question. Let's start off there. What is a linear equation?
I was not prepared for this.
Nobody knows. It's okay. You are not the only one.
And
I know.
I do not know math that well. And grammar, I guess. I get. Well, I mean.
All right.
Oh,
so
no,
let's make this. We're gonna start off real simple. We're gonna start off real easy. Okay. We can call these line equations. We're making lines.
Liner equations.
Line equations. Does that sound easier? I mean,
Yes.
Yeah,
what is a line? Okay, so this is one of these questions. I think Levi asked it last time. It was like, what is living? You know, sometimes the simplest question can be the hardest. What is a line?
An infinite,
An infinite.
two-dimensional. It's an infinite two-dimensional thing. It's an infinite two-dimensional thing that goes on forever.
Is it have to be two-dimensional?
Yes, yes, it does.
Okay.
I mean, no.
I mean, sometimes it doesn't.
I mean, like, but line
In very
is
rare situations, a line does not have to be 2D.
what in what situation would that be?
A very rare one.
So mathematicians have a definition, okay, and it's called we plot this through what we call linear equations or line equations. So there is an actual equation or a line, okay. And the simplest way, I was going to get into the equations today, but the simplest way to demonstrate this is through graphing. Okay. And you guys should definitely memorize this, because if anyone goes, oh, you're learning linear equations, this is what you're going to quote. Okay. Has anybody seen y equals mx plus b?
Never heard of that.
Nope, I have.
I was going to say, Grace, I know you have.
Yeah, I know. Yeah,
Nope.
I think you all expected Grace to know.
Oh, I know this one. I've seen this one before. That's like the graphing. That's what you use for graphing.
Okay, right. So I would like you guys to know, as we're starting to do algebraic equations, the reason why we're finding X, the reason why we're finding Y, okay? And it all starts with linear equations and graphing, okay? So in this, so any line, and you can write this down, is described in two parts. So two things describe a line. Okay. Number one is going to be its tilt. Does anybody know what the actual mathematical term for the tilt of a line is called?
Graph?
Like, the slope. The slope. That's what it is.
The slope. Okay. The other thing that describes a line is going to be where
Slope.
it crosses the y-axis. Okay, everybody knows what a y-axis. When I say y-axis, I mean this is the x-axis and this is the y, right?
Yeah, the y-intercept.
Thank you, Grace. Okay, that is called the y-intercept. So there are two things that describes a line, and that's the slope and the y-intercept. Okay, and this is going to be part of this wonderful equation. I want everyone to say it. Y equals mx plus b. Everybody.
Y equals mx plus b.
Okay, you're going to say that 80 bazillion times in your mathematical career. And when you're 40 years old, like me, and somebody goes, I'm learning linear equations, you're going to go, oh, y equals mx plus b. It's going to be drilled into your brain. Okay.
B is the slope, right?
That sounds fun.
Okay, so let's describe what that is. That's right. So the tilt or the slope, so number one, is going to be m. So that is the slope of a line. Okay. This is going to be your y-intercept. All right, so what does that mean? I have this cool thing. I don't know if you guys have. This is called Desmos. It's a free program, but if you have a graphing calculator, you can absolutely put this in your graphing calculator. If not,
I don't know how to use my graphing calculator.
Okay, if you we'll show you guys that here in a second. So if you want to go to, if you have an iPad or a computer in front of you, you can go to Desmos. There's an app for this, or you can actually go online. But I'm going to show you something real quick. All right, so here is, can you guys see y equals mx plus b? And we have a line.
Yes.
Okay, so what is m again?
The slope.
The slope of the line. All right. So slope just means how it's tilted. So I'm going to change m. Are y'all ready?
Wow.
Do you see the tilt changing?
Yes.
Oh,
Okay.
oh, that's
You're doing this. How are you doing this?
Is that what a graphing calculator does?
Yes, it does.
It's
Okay.
Okay. So this just changes the slope of a line. And we're going to get into what that is. Okay. The slope is just how it's tilted. Okay. Some people will denote this as rise over run. Have you guys heard of that?
That's, yep.
Yes.
Okay. So that means how far up it goes and how far over it goes. Okay. So how far you rise up and how far you run over. Okay. And that's going to be the slope of this line, or the tilt. All right, now let's put this back over here. Now I'm going to change the y-intercept of this line. So this is going to change at what point this line hits the y-axis. Okay, do you see it? Okay, with these 2 points, we'll be able to figure out where x is and what the line looks like. Okay. So that's going to be what we're solving when we do, like if you just see an algebraic equation, why are we solving for X? Why are we solving for Y? This could be, you know, you might find the distance between 2 points or something. There's so many different things that you could actually figure out with these equations. But I wanted to show you guys graphically what these two means and how the line changes when the numbers change. Notice that, you know, the line can go negative, positive, it can go all sorts of ways. You could, as long, all these numbers can constitute a line. Okay, up, down, there's your infinity, right? All the way up and down. Infinite amount of numbers. Now, what it won't have is exponents greater than 1. Okay, our X there has to be 1 as an exponent. And it won't have exponents that are fractional form. Okay, so it has to be a non-negative integer number. All right, so let's put one in. Okay, so let's graph something. Let's say I have an equation that is y equals negative 3x plus 4. What does that mean? So
would it be if 3 being the slope number and 4 being the y-axis number?
That's right. So let's go ahead and put our y-intercept in there. We'll do 1, 2, 3, 4. Okay, so at some point it's going to have a dot here. Okay, and this is our slope. Now this can be negative 3 is the coefficient for x, so that's our m. Negative 3 can be written negative 3 over 1, correct?
I did that.
Okay, so that's our rise over our run. So what that means is negative 3 is not really a rise, is it? It's more like a fall.
Yeah.
Okay, so we're going to
like
fall.
A ascend more than a descend.
That's right. So we're going to fall negative 3. Thank you, Grace. Perfect. So what that means, though, is for every, yes, exactly. So for every one space, like Grace did, she went over 1, you're going to fall 3. And then she put her point in. So she's going to run over 1 and she's going to fall 3. Cool?
Ooh.
All right. So let's do it again. Are you all ready? We're going to run 1 and we're going to fall another 3. Okay. So we're going to go 1, 2, 3. Let's go 1, 2, 3. Here's our other point. We ran 3. I'm sorry, we fell 3.
So,
All right, now we've created a line. So this equation has now created a line, right? It's sorry, my line is terrible. But now we've created this line. And with this equation, you can now, like this dot here, you could find negative 6 over 2. Because that is going to also equal negative 3 over 1. So each one will come back. We can put in an X for a number here, and we should be able to get a line. Let's actually graph it. So this is where I'm going to get out of all of these. And on this graph, we're going to say negative 3x plus 4. Look it. Does that look like what the line we made?
Yeah.
There you go. So here's our line. Now, with this, we can find any point on this line, which is going to come in handy in life. right? Later on in life. And we'll start, as we progress, you'll start understanding word problems with these, okay? Any questions? We're going to keep going. Okay.
No questions.
So let's make another one. Okay. What if we just have a line? Like, let's say we can make estimates. All right. What if I have something that looks like, let's see. Let's put it as something like that. Okay. And I say, okay, y equals mx plus b. Okay. Now I know my y-intercept. Okay. That's going to be 4. Now, again, this is approximate. It could be a little more, a little less, but we're approximating. So if I know my y-intercept, can I approximate my slope here? So let's say that's my point of my slope. This is a -2. So I have y equals slope of a line plus 4. So what would be my rise over run on this one? I would rise
That
what?
would be 4.
No, I'm rising.
Oh,
because-
-2.
So you're actually you're rising +2, right? This is 2. And I'm running what?
4 is the x-intercept.
You're right. You're right. Thank you, Grace. Look, I gotta keep, you guys are smarter than me. The y-intercept is, the y-intercept is what, Grace?
Smarter.
-2.
Thank you. Very good. Okay. So we have our rise over run plus our y-intercept. Thank you, Grace. We can reduce 2 over 4 to what?
-2.
1 over 2, right? 2 over 4 is also
Oh, 1 over 2, yes. A half.
minus 2. Oh, we got to have an X in there. So this would be our approximate answer for this line.
This is my answer.
Yeah, it's like those really hard math
So-
problems. You think that they're really hard answers, but they're really not.
They're really not. All you're doing is counting the number line back and forth, right? Once you know the equation. Okay, so now to get a precise answer, we're going to need 2 points on a line. So that's going to be your key. All right, so I'm going to actually give you 2 points on a line and you can give me the equation. Okay, so the 2 points, so here is my line. Let's see. I'm going to actually make a better line this time. We'll do that. There we go. All right, your first point on the line is going to be 1, 1. And your second point is going to be, we'll go right here. And we'll make it 3, 4. Never mind if I actually, this looks like that, but here's our 2 points of a line. All right, so what is our equation? Y equals mx plus b.
mx plus b.
Okay, you're just gonna continue repeating that because you gotta memorize it.
Yeah.
So anytime I say, what's the equation for a line? You just say it out loud.
mx plus b.
Okay,
Your
So
dimensions
our-
are really confusing for me.
so what's our slope? Okay, so m is our slope.
3, 4.
So it is 3/4, but it's a negative, right?
Oh,
Because we're not
Yeah.
rising, we're falling.
running down.
That's right. So when you get into math class, there's actually a formula for rise over run. Does anybody know it? Okay. So all it is it's saying y2 minus y1 over x2 minus x1. Let's see if we can work that out. So when you write 2 points of a line, it's x and y, right? There's the x and there's the y. So you take the y1 or y2 minus y1. So all you're doing is you're going from here down to here. How long is this? Okay. And you go, okay, well, the y on this one is 4 and the y on this one is 1. So we're going to get a 3. We're descending 3. Okay. And then you take the same thing with an x. And you're going, okay, well, I have a 3 on an x here. And I'm going over like a -3 on this side. And then I have, yeah, because this is a negative. And then I have a 1 over here. So this is going to equal 4. That is 4 spaces because you got to go all the way to 0 and then add another one. Does everyone see that? You have 3 spaces to go here and then 1 on this side. All right. So our slope is now -3 over 4. Do I need to, we're good?
Yeah, we understand.
Okay.
Well, hold on. Let me look at it for a second.
Okay, I was about to say, stew on it for a minute here. You went down 3, and the spaces you had 4. So you can subtract the y's over the x's. So the difference between the y's and then the difference between the x's.
I'm getting 3 over 2.
It's a little bit confusing, but okay.
Maybe I should write it out. Would that help if we put in the
A little bit.
Yes.
Okay, so let's put in the actual slope here of 2 points of this line. All right, I'm going to do it in green. All right, what is y2? We're going down to this one, so we'll designate this as the second line. So we're going to say 1.
1 minus 3.
Oh, of course, yeah, let's not do that. Of course, this is going to be a -3, correct? Because I'm on the negative space. So we can say, to make things look better, let's see, we're going to do a... that would be 4.
Got very quiet.
Right, okay, so that's an X. There we go, those are X's. And then our Y's are going to be, which one do we start with? 4 minus 1. Here's our Y's. And here's our X's. Does everyone see that?
Yes.
Okay. So then we get 4 minus 1 is 3. And then the bottom one is 4. Okay. And we're on we descended. So that's a -3/4. Now, once we plug the slope in, we can solve. We can plug any point on this line on any, we can pick this 1, 1 point. All right. So we have y equals 3/4 x plus b. Okay, so we're actually going to plug in 1 for x. We can plug this point in because if this is true, which it is, this should work out. So we're going to plug in 1 for y and 1 for x. And our y-intercept is 1 3/4. So what I want you to know, so I don't want to let us get lost in the weeds here. What I really want you to gather from this is picking points on a line and what this equation is actually trying to tell us. Okay, so once we know y equals mx plus b, and we have 2 points on a line, we can find the slope of that line. And when we find the slope of the line, we can pick one of those points on the line and we can find every single point on that line. And it might actually be better if I actually graph it for you guys. Let's actually graph this. So I want to do, let's see if they have here we go, slope. So here is our slope. So here's our x2 minus x1 over y2 minus y1. Now, do you notice on this equation, they don't have m by itself, right? So if you just go ahead and divide by x to the other side, it'll be y2 minus y1 over x2 minus x1. Does everyone see that?
Okay, let me put that in.
Well, you don't have to put, so basically you're saying is if x changes, the slope at which the tilt is does not change. Let's see the slope. What there's y changing. The only way we can change slope is if we actually change m, the 2 differences. Okay. Everyone see that? Okay. So the find a slope of a line is going to be the difference between the y's of 2 points and the x's of 2 points. That's the takeaway. Yes, no, maybe so. Does everybody understand that?
Yes.
Okay, let's try a practical problem here. I want to show you guys. We'll come back to that if it gets too confusing. We will be on this for a little while. Linear functions are very important. Okay, let's say I'm going to show you a practical version of a linear equation. All right, let's say we have a bench, or we're trying to build a bench. Who wants to build a bench?
No.
Here's my bench that looks, maybe I should make that a little better. All right, how about that? That looks like a bench.
That's a depressing bench.
All right.
That's one depressing bench.
I know. I'm so sorry. All right. You have 10 foot of wood, okay, to build this bench.
That's a large bench.
Or small, depending if it's the size of a piece of paper. All right. You have 10 feet of wood is your total amount of wood you have to build this bench. Now, your only stipulation is this bench to be stable, to have a stable bench. The top needs to be 3 times longer than the legs. Can anybody think of a good equation for this? So we can just make the legs x. Okay. So we know at some point the top needs to be 3 times longer than the legs.
10.
So we'll say this is 3 times whatever the length of one of the legs are.
10, 3x, x.
Yes. We're missing a sign in there. We're missing a few signs. So our total that we can use is 10. Okay. So that's going to be what we would generally call our Y, which is our output. This is how much we have, 10. Now to build it, it's 1x plus another leg, plus the top, which needs to be 3x. Does everyone agree?
Yes.
Okay. So let's solve what x needs to be before we cut. So how long does the legs need to be? How long does the tabletop going to be? So we have 10 feet of wood. So how long is each leg? How big of a table can we make?
A small table.
Let's go and add these up. We have 10 feet.
5x.
Yeah, we have 5x. Okay. Now we want to only have the variable on one side. We're solving for x. We need to know how long each of these things can be. So
we divide 5 from 5x and then divide 5, that's 2.
That's right. So we
x
divide 5 out from one side, and whatever we do to one side, we have to do to the other side. They're equal. So now we have 2 is equal to x. So each of the legs is how long?
Yes.
How long is each of the legs?
2
feet.
feet.
And then how long is our tabletop, our bench top?
10 feet.
No, you only have 10 feet of wood.
That's what I just said.
Now, how long is the top? So if each of these are 2 feet, how long is the top?
Oh,
8 feet.
5.
So all you're doing is plugging X in here. It needs to be 3 times.
6.
Yes. So your tabletop is now 6 feet. Okay. What? Did somebody say something? Okay. So there's a very simple linear equation with 1x. Okay. All right. Let's get a little more complicated so you can see it in your y equals mx plus b form. All right.
Okay.
So you're now at a grocery store. You're now at a grocery store and you have a conundrum, okay? Because what you're going to find is there's 2 lines. There's 2 cashiers open, okay? And the first cashier is part of the express lane, right? And she's going to check you out. That's the express lane. And then you're going to have the regular lane, okay? We'll put that as R. All right. The thing is in the express lane, there are 4 people. Okay. This person has 3 items in their cart. This person has 5 items in their cart. This person has 2, and this person has 1. Okay. Now, in the regular line, there's actually only 1 person ahead of you, but they happen to have 19 items in their cart. What line do you pick?
The express line.
Express.
Okay. So what we're going to need to know for this, and I'm actually going to erase this part so I can. What we're going to need to know for this is the time it takes per item, right?
Mm-hmm.
That sounds like an important thing. So we need to know the time it takes per item. What else are we going to need to know in order to solve this problem?
How many people per lane?
Okay, we know you're right. We have 4 in one, and then 1 in another.
They're gonna take slow to.
What happens when you check out? What happens after you check out?
You gotta bag them.
Okay. And what else?
Pay for it.
Them in your
You have to
basket.
pay for it. Okay. So we also have to know the time it takes to pay each person to pay, right? Because that factors into how long that person is standing there, right? So we need to know how much per item.
Doesn't that depend on how many groceries they have?
No. The time it takes to pay would be the same. Yes.
Okay.
We're assuming you have like the same paying method, like a card or something, right? Okay, so with these things, we can actually write our linear equation. All right, so how we're going to do this is something that you guys might see. Have you guys ever seen that fx?
No.
Yes.
Okay, that also equals y. Those can be kind of interchanged. All this means is the number of items or the output of each person. Okay, so the number of items is the output of the number of items. So how much time it's going to take, okay, is going to be equal to, well, each person takes 40 seconds is what we're going to say to pay. They've actually done this study, and it takes 40 seconds to pay on average. And per item, it takes about 3 seconds to check out one item. Okay, so we have 40 seconds to pay, and then plus 3 seconds per item. So the item would be X. So the more items you have, the more seconds you take. Does everybody make sense?
That's what I was asking. I was thinking earlier, it depends on how many groceries they have, not what type of card.
Oh, what? Well, yes.
Yes.
There would be a standard amount of time to pay, but yes, if you're talking about how long total, yes. It's going to be 3 seconds per item. So obviously you're going to stand there a while if you have more items. Okay, so let's solve it. All right, let's see which lane would be the better lane. So this first one is, okay, we have 40 seconds to pay plus 3 times what?
I have stuff to do later, so I'm gonna go.
Okay.
Bye.
You normal
Bye.
human.
All right, so we got 40 seconds to pay, 3 seconds. How many items did they have?
3.
3. All right, let's do the next person. We have 40 seconds.
The regular line is better.
Yeah. So we have 40 seconds plus 3 seconds times 5. All right, 5 items. This one is 40 seconds to pay plus 3 seconds for 2 items, every 2 items, okay? Then we have 40 plus 3 and only 1 item. So let's add all this up. So we have, how many 40s do we have here?
A lot.
We have 4 40 seconds. All right, how many 3s do we have here? We got 11. Because we have 11 items total on this side, right? Okay, so who has a calculator? Who can add this up?
I have a calculator.
All right, we have 4 40s, or you can do this in your head, honestly, plus 3 seconds for a total of 11 items.
193.
Thank you. Good job.
Seconds.
This line will take 193 seconds. All right, now let's do the
That's a lot
regular.
of time.
So the regular line
The
is
regular one will take 97 seconds.
okay. So we have very good. So we have 40 seconds to check out, plus 3 times 19 items, and that equals 97 seconds to check out.
How many items do we have so we actually care for the people behind us?
Miss Sarah.
We're the mathematicians
X-
waiting in line, so we have the advantage.
No, Miss Tara. So
Yes.
a small problem. Actually, the executive line, I don't even know what it's called. That'll actually be shorter because by the time we're done doing all this math, the regular line will be filled with more people with 20 items.
Well, that's why you have to be super quick and do this all in your head.
By the time we are done with this calculating, the store will be closed.
Yeah.
And
Wait,
we
wait,
no-
wait.
Like,
How many items are in the cart anyway? We're not the ladies at the Costco exit.
well, this
Extra
should
items.
tell you by this mathematical equation here, this y equals mx plus b, right? That the limiting factor is not the number of items, is it? The limiting factor seems to be the 40 seconds it takes per person to check out. Because technically there's only 11 items in the express lane.
So that's only 33 seconds.
That's right. That's only 33 seconds. So you always choose the lane with less people in it.
Yes.
All right. How do we feel today? Let's see. It's 1:30. We've actually hit our limit. I was going to start 2 variable linear equations. So next time we're going to actually do something that looks like this, which is a line.
What is this?
And we're going to find where 2 lines. How do we find that mystery? Where 2 lines intersect.
Oh Lord.
So we'll actually have 2 lines that are intersecting, and we'll have 2 variables to this equation. And that is called a 2-variable linear equation, a multivariable. Okay, so that's what we'll do next time. And we're going to start with 2 different methods, the substitution and elimination method. And that's just plugging in x for one equation into another. It's actually not very difficult. And then we'll start also doing some more practical applications of linear equations. So there you go. That's math class today, guys.
Yes.
We'll go over this more and more next time. We can go, I didn't go super in depth on slope and line and intercept and all that kind of stuff. It gets very, like when you get into geometry, we'll really get into that. But I wanted you to know what a line was and what we're actually trying to solve for. Because all these could be graphed in a linear way. So like this last grocery store equation, so although it doesn't look like y equals, it actually looks like y equals, and to make this look like mx plus b, we'll do 3x plus 40. That is your line. Okay, so 40 would be your y-intercept and 3 would be your slope. And you could actually, we could try to graph it if you want. See what it actually looks like. And then whatever you put in for x, it should be able to solve. You should get your output, your y. And you can actually see this on a graphical line. Any questions?
Nope.
Okay.
Happy birthday, Miss Tara.
Happy
Yeah.
birthday, Miss Tara.
Oh, thank you. Yes, happy birthday
birthday,
to
Mother.
Desiree too, right? Did she leave already?
Yeah.
Oh, no, is he still there?
Nope, I'm right here.
All right, everybody sing happy birthday to Desiree. 1, 2, 3.
Happy birthday,
birthday
happy birthday to you. Happy birthday to you.
Happy birthday.
dear
Emma.
Desiree.
Are you trying to do an accent?
No.
Hold on. There we go. Now we can see you. How old are you, Desiree?
14 today.
Ah,
Wow.
we're getting old. I love it. What you guys doing today? Anything fun?
At this current moment, heading to chemistry.
Oh, chemistry class. Okay.
Yep.
Is that at
Teaching
the
chemistry, so we're doing something with clams. I'm not entirely sure what.
Oh, okay.
Yeah.
Nice. Is that with a co-op or at the Beaker place?
I mean, it's just with one other family, so.
Okay, so with your co-op thing. Okay. Awesome.
It's fun. Yeah.
Well, have fun, everybody. I'm doing laundry today for my birthday, so enjoy being 14.
Emma, do the laundry for your mom.
Yes, do the laundry for your mom.
That would make her so happy.
That's my birthday present.
Well, thank you for the class, Miss Tara.
Yeah, sure. We'll do some more graphing and lines next time. Have a good rest of your day, guys. Is anybody else finished doing more math later today?